Testing, testing, 1, 2, 3, testing, testing. Hello, everyone. I hope you're all doing well today. Maybe you are, maybe you aren't. But what I do know is I'm here, and that's what's important. Good. Excellent. So, what? He actually loaded the slides beforehand today? Crazy. So, I don't think there's anything particularly of note to speak about today, so why don't we just get right into the dealio. Yeah, I remember now. We were doing it in a different B-Day. There we go. Okay, so we had just started on our, I think, final example here, which was the mean calculator. It's not a calculator that says mean things. It's a calculator that calculates the mean in a statistical sense. Would I ever seriously consider changing the intro waiting song, or is it too much trouble to be bothered about? It's getting a little old, eh? Yeah, I could do that. It's not really a difficult thing to perform in OBS itself. It's more of a, I have to go out into like royalty-free music download services and find something appropriate, if that makes sense. So, you know, yeah, okay. Getting a little tired of Prelude in C? That's fine. You know, I could just say something like, well, you know, realistically speaking, you only have 3 more weeks of it to go anyway, so, you know, is it really worth the trouble of changing? Because, you know, if it's only 3 more weeks and then next semester it's a whole new class, and the whole new class is like, you know, but anyway, yeah, okay, I'll take a look at it. Apparently there's this thing that you should be able to do, with, like, having a folder full of music and, like, having, what's it called? Not DLC, the media player that's the traffic cone, whatever it's called. Apparently if you can, like, have that running in the background and have the feed for that feeding into OBS, which means that you can, like, loop through and play an entire folder of music selections. I just haven't, generated a folder full of music selection. DLC, what am I talking about? Thank you, Nicholas. Yeah, I just haven't bothered collecting up a library of music for that. I missed the Monday and Tuesday lectures. Not sure if I can catch up now without viewing them first. Yeah, I think you should probably go watch them first. Don't worry, because you can watch them at, like, twice speed, and then, by the time this lecture segment is finished, you'll have seen both of the previous lectures, and then you can watch this one at half speed, too, so it's only a 50%, time penalty for having done that. Anyway, so we were talking about the mean calculator. Our intuitive implementation of the mean calculator just took every element that you add to the mean calculator, dumps it into one big list, and then when you ask for the mean, it returns the mean of the elements in that list. You know, fairly straightforward. Fairly intuitive, and that's what our first implementation is right here. We are storing everything in a list. So, this is not the only way of going about this. The advantage of this is that it's expandable to other types of statistical analysis that we might wish to perform, that we might want to add later to this class. If this class, like, if later on you wanted to add something like mean, median, or mode, or standard deviation, you have a suitable basis here for expanding this into a whole statistics package. Pardon me. But if all you need to calculate is the mean, we can actually do this with far less memory consumption if we make a couple of assumptions. So let's do a second class, mcalc2, inherits from object. Rather than keeping a list of all of the elements that we wish to calculate the mean over, we actually only need to know two things: a running sum and a running number of elements. So we could say shloop self.sum is equal to 0 upon initialization, and self.elements is equal to 0 upon, we could even call that self.n is equal to 0 upon initialization. So if we then define our adding function in light of this, taking self and n, or let's call it v for value now, because n is, we don't want namespace conflicts. Self.sum plus equals the value. Oh my god, I'm adding semicolons. I've been programming in C again, guys. Self.n plus equals 1. And then, if we wish to calculate the mean, we want to calculate the men. Impossible, they are incalculable. We might also wrap this in a try except in the case where, or you could just do an if statement. If self.n does not equal 0, return self.sum divided by self.n, else return 0. Sure. And this does the same thing, but you notice we don't have to maintain that data structure. Instead, we only have to maintain two integers, which is far less memory intensive. Boop. Cool. So that's another way of going about calculating the mean. Mean calculator 2 computes the mean arithmetic average of a collection of numbers. I suppose I should actually demonstrate that this thing works, eh? So, if we instantiate, let's say calc is equal to mcalc1 calc.add 4 8, 7, 36, and 1. Print calc.mean, and that should have the desired effect. Python 3 bday.py, and our average is 11.2. If we modify this so that we are instantiating mcalc2 instead of mcalc1, you will see that we get an error. Mcalc2 has no object attribute sum. Are you sure? Are we sure about this? Oh yes, because I did int instead of init. What a silly person. There we go. Now it works. So, I may have said this before, but I see it as a useful exercise when I'm live coding something for you. If I make a mistake while I'm doing stuff, you guys get to see me fix it in real time, which is, I hope, instructive. So, So this is good. Question. If only add and mean are used, can mean calculator 1 and mean calculator 2 be distinguished? The thing, like the question that we're, and I'll give you guys a moment to answer this question in the chat. Do you think mean calculator 1 and mean calculator 2 can be distinguished? There's an asterisk there, and the asterisk says, from the perspective of the end user. What do you guys think? Can these two be distinguished from the perspective of the end user? Quick Draw Hansen says no. Everybody else is asleep. No? Question mark? No? No? Are you asking if we could get a different output with the same input? Well, I'm asking kind of a more broad question than that, actually. So, lots of people are saying no, that seems to be the consensus, not unless they're measuring runtime. Now, that's an interesting one there. So, yeah. So, hell no. So, I'm reminded of the meme, well, yes, but actually no. From the perspective of functionality, from a black box testing perspective, these two things are identical. However, if you start digging underneath the surface a little bit, you will find that the more efficient one runs more efficiently, therefore takes less time and takes less memory. So if you are profiling your code in any way, it is possible to tell whether or not the implementation you're using is more or less efficient. However, again, from a black box sort of bare functionality perspective, there's no way to tell the difference between these two things, especially if if all of the member attributes were private. One could also make the argument that you could have the sort of implicit interface with it of, if you knew that this list existed, you could access it and modify it and do things with it, sort of outside of the defined means of access of the function. But again, that's sort of not. The question says if only add and mean are used. So, there you go. I don't know how the efficiency compares. If one much more efficient than the other, the user might notice a difference with large collections. That's a good answer. The user might notice a runtime difference with large collections. Good. Good answerings. So. So let's talk about abstraction. Functions provide functional or algorithmic abstraction. Functions can be used without needing to know the algorithm they implement. The documentation specifies declaratively what a function computes. So that's just a fancy way of saying functions hide instructions from you. And you don't need to know how the function has been constructed. You only need to know what it should take as input and what it should produce as output, as long as the function has been written correctly. Classes provide data abstraction. Classes can be used without needing to know the data structures of the implementation. The documentation refers to the abstract data structures that may not be present in the implementation. So, in the same way that a function, in the same way that the user does not need to know the particular instructions that go into the construction of a function, the user does not need to know the particular data structures or, the arrangement of variables that go into the construction of a class in order to be able to use that class. It's the same kind of abstract layer, but we're integrating instructions with data structures themselves. So let's talk about hiding stuff. Data abstraction of classes assumes that the attributes are not manipulated from outside the class, right? As I said, you can tell the difference between these two things if you are manipulating the internal data representations from outside the class. However, if you are restricted from doing so, then, you can actually enforce the data policies that you want. So nothing actually prevents outside functions from accessing and modifying contents of member variables, which can lead to inconsistent states. For example, if, user A has been accessing this an object of this class and has been dutifully adding all of their data points to this class, and then user B comes along and decides to just wipe out all of the work that user A has done, unbeknownst to user A, and then user A tries, adds a few more, and then tries to read the mean that they read will not be the actual mean, but they might not realize the problem, because the mean might still be meaningful, so to speak. It's just, a large swath of the data has been blown out by another user because they had direct access to the internal data representation, and they were not accessing things through the specified means of access. This is what we mean by things like this can lead to an inconsistent state. If you prefix a member by _, the member will be private. Python will prevent any code outside the class from accessing private members. Let's see if we have any questions. Boop. Nope. So, for example, if we wish to protect our data in our mean calculator class, all we have to do is prefix each of these guys with a _. Now, there are various things you could say about this. Like, Mr. Professor, sir, I am a person who has worked in other programming languages, and this seems like a terrible way of assigning private membership to elements of a class, and I would say, you're absolutely right. It is frankly a bit ridiculous that, as a design choice, Python decided that you had to add characters to every single use of an identifier in order to designate it as a private member. That is silly and ridiculous. Most programming languages would have you do something like that. However, you may notice that Python kind of has a phobia of, prefixed prefixing identifier tags to things. So yeah, it's ridiculous and redundant to have to prefix all of these private members with _, because you have to remember to do it each time. You can't just set it and forget it. But, that's Python. If you want to have a better programming language, you should use basically anything else. Wah! Burn on Python once again. But anyway, so the difference between these, if, for example, mcalc2, we wanted to do calc.l is equal to the empty list, after having added a few things, you'll see that this will result... Oh, did I not save it? Save. Oh, it's .rec, not .l. That wrecked. Nobody really says rec anymore. So that, that's the average of just 1, which is what you would expect to happen. If we made this into mcalc2 and we tried to reset the sum to 0, for example, you'll see that what we end up with is just the average. So you might think that this would result in an access violation. Oh, wait. So, so the interesting thing about private members in Python classes is that this double underscore is actually considered part of the name of the identifier itself. So when I do this right here, what's actually happening is the class is creating another field within itself called calc.sum without the double underscore and giving it 0. So if we want to access sum with the double underscore, we actually have to try to do it out here. And you'll notice that if we attempt to do so, we get nothing again. It's prevented from happening. So it just does nothing rather than tripping an access violation, which might be an important and useful thing to know. In some languages, trying to access a private variable like a private member like this will result in an access violation. However, I guess it's like a security policy on the part of Python that it's not going to tell you whether or not an attribute exists inside of the class you're trying to access it in, because that information could be, used for malicious purposes, I guess. But yeah, so that's private members. What is the point of having private members? Got a few questions. Question: why does the mean calculator class on the slides not have object? Because it doesn't need anything that object needs, or object provides, I suppose. It's never a bad thing to inherit from object, but, we don't necessarily need it. You don't need object necessarily, and if you have, empty braces, you can remove them. It'll work perfectly fine in both cases. But yeah, inheriting from object is never a bad idea, but it's not necessary in all cases. What if you define sum with underscore sum and without in the same program? Then one is, like, they would be maintained separately. You would have, like, a private and a public. If you used them the same, you would have a private and a public version of the same thing. See? There's no namespace conflict. Things with double underscores do not conflict with things without. They are separately, they are considered separate variables, just completely distinct. Like Haskell, C++ or C# is the way to go. I agree. Yeah. Java's also not bad. So double underscore is the same as declaring a variable. Private? Yes. What's the point of having private members? So private members make the black box blacker. Yes, that's a good way to put it. So in software design, you have a design principle called the principle of least privilege. And that principle states that any particular program should only be able to access that which is necessary for it to access in order to accomplish the task it's trying to accomplish. So one example that I like to use of this is, let's imagine you had a paint program. You know, a program that produces images and works on image files. It works on .pngs or bitmaps or whatever. Does that program need access to your operating system functions? Like, does it need access to, say, your network? Does it need to go out onto the internet? It depends, right? In most cases, no. One could argue that maybe the thing's got like a self-updater that can go out on the internet and check for updates. Fine. But generally speaking, a program that simple would be updated by, you know, if it's maintained by the operating system, it would be updated by the operating system. It doesn't need access to the internet in order to modify a bitmap image, right? So don't give it access to the internet. You know, the more barriers that you put in place to restrict programs from not accessing things that they don't need access to, the fewer doors you're leaving open for hackers, essentially. So when you create a class with private members, you are closing doors to people who may not have the best intentions at heart when they are exploring or trying to use your program. And it doesn't even necessarily have to be a matter of trying to block malicious activity either. It could be a simple matter of you don't necessarily trust someone else to be a competent programmer. So a person who doesn't know what they're doing can do a lot of damage. You know, if the access privileges are unrestricted and the person just has no idea what they're doing, then they can cause lots and lots of problems. Like, for example, in Linux, all it takes to completely delete everything within a directory is 7 characters. rm space -r space star, which is recursively delete everything in your folder. If you attempt to, as the user, to do this to your own like your home directory or your documents folder, it will not give you any trouble with that. Although I think in some distros it prompts you to say, are you sure you want to do that? However, if you try to do that to your operating system on Linux, you have to invoke super user privileges to be able to do that. In Linux, a super user is kind of like giving yourself administrator privileges in Windows. So you can do it, but you are required to enter a password first. And, you know, hopefully if you are entering the password for super user privileges, you are thinking about what you're doing. You can't just casually delete your operating system. But, you know, principle of least privilege, basically speaking. So is it always better to make it private? So it's not always, like, again, it depends on the application, but yeah, generally speaking, making things private is better. Although, please don't do that on the test, because we need to be able to see your variables in order to be able to mark your classes correctly using the auto-grader. So your clock app doesn't need to access your camera and microphone. Not generally. Yes. Yeah, that's actually a much better analogy. Does Solitaire need access to your microphone on your smartphone or tablet device? Probably not. So should you give it to it, even if it asks? Probably not. Yeah. Privileges are, yeah, that actually makes a lot more sense within the context of a smartphone. Yeah. here's a fun little example. Let's, just as a mental exercise, let's come up with some classes to represent objects in common video game that everybody played, except nobody played. Maybe some people played. I don't know. This one was on the Wii U, so probably not many people played it. I think this was one was on the Wii U. It might have been on the Wii. Give me a second here. Misinformation. This one was on the Wii. So this one, this Mario game, would have been played by many millions of people. Anyway, so let's think about this for a second. What classes would you guys say this Mario game, which is Super Mario Bros. Wii, up to 4 players for fun, which things inside of this virtual environment, what classes would we have? And think also about inheritance here. Like, what classes of objects would there be, and what specific objects would there be? I will wait for responses. Galaxy was where it's at. Yeah, well, you know, if you're not playing Sunshine, then don't even talk to me, man. Nothing beats Jetpack. Nothing beats Jetpack. So, playable characters would be a class. That would be accurate. Enemies would be a class. The blocks would be a class. Characters would be a class. Yes. So yeah. So the player would be a class. But let's talk about Goomba for a moment. So, oh my gosh, shut up, me. There we go. So let's imagine Goomba. Goomba would be a class that would inherit from enemy, and enemy would be like a class that would inherit from character object, right? But interestingly, we have a difference here between the Paragoomba and the regular Goomba. You could say that the Paragoomba is a enemy that inherits. It's an object that inherits from both Goomba and Wings, because you'll notice that there are actually a few different enemy types in Mario games that have the same wings attached to them. In fact, some of the power-up items, I think, eventually had wings attached to them as well. So, you know, how a Goomba interprets having wings is different from how a red-shelled Koopa interprets having access to the wing, inheriting from wings, and how the green-shelled Koopas have wings. They're all different things, but, like, that's kind of how you would do such a thing. A general class for enemies, more specific classes for enemy types. Yes. Points or coins. So points would be like an integer somewhere, but coins are objects within the game because they're interactable in the game. Yeah, so anyway, yes, and you can kind of imagine that, if you imagine like the Tanuki tail, right? The Tanuki tail would be another class that Mario would inherit from, as well as like the playable character class, where he probably inherits all of the control-related code from, right? Yeah, so pickup items. pickup items would, like, basically coins and mushrooms would be in the same, like, they are interacted with in very similar ways, right? Basically, any intersection between the character object and the pickup object will cause the pickup to disappear with, playing some thing, some animation and some sound effect, and then some state variable gets modified. Yoshi is also, I would say Yoshi is a class in and of himself as well. Although it really depends. Yoshi, when he's in the field, would be an interactable object in some sense, but it's kind of ambiguous as to whether a Yoshi that is being ridden by a playable character is, in fact, his own interactable object. In my opinion, Yoshi would cease to be an interactable object and become a power-up. So, Yoshi, there's really, in terms of, like, effect, there's not much difference between Yoshi as ridden by Mario and, like, the Tanuki tail as worn by Mario. Yeah. So, anyway, let's see what the slides have to say. Suppose you want to create a set of data structures for representing the initial state of a Mario level. What classes would you create? Which ones would be subclasses of the other? What properties and methods would those classes have? So there are a couple of other things that I'd like to dwell on before we move on even from here. We touched on it briefly, but even elements of the level itself are objects of classes, right? Brick blocks are objects. Question blocks are objects. Used question blocks are objects. Pipes are objects. The ground is objects. The Yoshi bush with the Yoshi fruit is objects. The one-way platforms are also objects. But yeah, so all of the background elements, one could even say that, the very pretty backgrounds that have the parallax scrolling effect are also types of objects, although they're not interactable. They're just there for decoration. Yoshi would be different to power-ups as he's not gained by colliding with him, but instead by jumping onto his back. Yeah, so in that sense, he's actually kind of a type of enemy, because that's how enemies are interacted with, right? Yeah. So, Yoshi's kind of an interesting one. And if you've actually played this game, you'll know that the other player characters are actually interacted... Oh. It must be in the Wii right now. My goodness. The other player characters are actually interacted with in a similar fashion. See, I would never have been able to get out the instruction manual if this were happening at the university. But, yeah, it's kind of interesting. Anyway, we're just about done classes. So here's an example of a possible class hierarchy for Mario. I'm not saying this is the correct one, but it's a possibility. So we've got the level. It contains a bunch of stuff. Characters are playable or non-playable. Non-playable would be things like Goombas and Koopas, and probably Yoshis as well. And then you have what are called widgets, which are interactable things in the environment. There would be blocks. So you have many different types of blocks in Mario games. You could have brick blocks, question mark blocks, used blocks, the bouncy music note box, etc., etc., etc. And something like a pipe. Pipes are sometimes go-downable and sometimes not go-downable. But, yeah, anyway. There are also... So now that we've broken it into the ideas of classes, we can also have properties and methods which we can think about with respect to these different classes. So let's talk about blocks. So if we have question mark block, which inherits from block, some possible properties would be things like, what is its position, x and y coordinates? inside of the game space. That's an important one. What are its contents? So the question mark blocks sometimes contain coins, sometimes contain power-ups. You know, the contents are hidden from the player, but known to the program, obviously. Whether or not the question mark block is used or not, that's an important state element. And it might have a couple of methods. Draw on screen, which, you know, obviously in order to render the object, it would have to have a method that would render the object. And although this is probably provided by default by whatever game engine Mario is running in, it's highly unlikely that all of this is done by hand. And then you would have a smash method, which would be the transition of the question mark block from the unused state to the used state, the disgorging of its contents, and, you know, the associated animation and sound effects. Class playable character. You could have such things as which character it is. Are you in big mode or small mode? Do you have a feather? Number of coins accumulated, X and Y positions. Move to. So, this sort of betrays the idea that this betrays the fact that the person who has made this set of slides hasn't actually made a video game before, because that's not how Mario moves. You do not select a point on the screen and Mario moves to that point. That's how a point-and-click adventure game, that's how the movement inside of a point-and-click adventure game works, like Secret of Monkey Island or that one with the skeleton boys. That's how those work. No, how Mario works is you have X and Y position, and you also have X and Y velocity and momentum. And when you like press left on the control stick, when the game receives input in the left direction, that causes momentum to be accumulated to Mario in that particular direction. That's why if you move the if you reverse directions on the control stick quickly, Mario still has rightward momentum that has to be reduced, and then he sort of skids and then he goes in the other direction. It's all about momentum. Collect coin, sure. Draw on screen, obviously. Jump would be a method. Take damage would be a method. Activated by collider intersections with enemy or damaging widget type objects. But yeah. So anyway, that's how you would construct a Mario game. Are there any questions about classes? Because that's the end of classes. I'm going to load. In class playable, what does X and Y represent? Those would be positions in the game space. So if you imagine this as a grid, right? You would have a certain Y position and a certain X position, right? And regardless of the sort of other considerations, whether or not the position of a character in the level would be its XY position relative to that grid, and that is actually how game engines work. What is the background? Is the background on Mario a class? Yeah, it would be. So here's the thing about video game development, right? Everything is object-oriented. So in a modern video game environment, such as Unity or Unreal Engine, these are object-oriented systems. I'll speak about Unity because I've actually done stuff with Unity in the past. If you guys are interested in seeing a game that your professor has actually developed, released, and published, and all of that, you can go onto Steam and look for Super Steampunk Pinball 2D. Super Steampunk Pinball 2D. That's a game that I made and released for fun. Made a little bit of money. Not very much money. So, inside of the game development environment, you have what are called game objects in Unity. And these are essentially classes that inherit from a bunch of other classes. So if I have, for example, a pinball bumper, right, it'll have a position in game space, right? But it will also have things like physics colliders. Physics colliders would be... Yes. Yeah, that's it. Pretty sure this is it. Yep, this is it. This is the game I made. Please forgive the amateurish attempt. But in this game, like the pinball bumpers, right? In order to detect an interaction between the pinball and the pinball bumper, both the pinball bumper and the pinball require what are called 2D colliders, circle colliders particularly. So, circle collider in Unity is what's called an attribute. I'm sorry, they call them components. So, you have a game object, and what that game object does is determined by the components that you attach to it. Now, attaching components to a game object is the same thing as making that class inherit those attributes, right? So, when you have a game object that has the 2D circle collider component, that gives it the properties it needs to have interactions with the physics system that that Unity provides as sort of a default sort of thing. That's the real big advantage of using a well supported engine, is that you don't have to do a lot of the work by hand. Like, actually programming a physics system within a video game is actually pretty labor-intensive and not a good use of your time if all you want to do is make a video game. People criticize Unity's physics engine quite a lot because people who don't know how to use it properly end up with, like, jelly characters with, like, hyper-extended flexors, and, if you haven't constrained your physics engine, your physics components properly, you can get like arms that vibrate out of the level, but they're still attached. So there's like a spaghetti strap connected to this arm that's on the other side of a collider. All kinds of crazy and weird and interesting stuff like that. But like fundamentally, it's object-oriented programming. And you've got a difference in Unity you've even got the difference between classes and objects. So in Unity, you've got a set of instantiated game objects, which are the ones that actually physically exist in this level. For this pinball table, like the flippers are instantiated objects. The pinball itself is an instantiated object. The turbo loops are instantiated objects. And in Unity, you've also got what are called prefabs, although what a prefab actually is it's an uninstantiated game object, which it's like having a library of game objects which you can like drag and drop into a particular scene. So these uninstantiated game objects are these are classes which are instantiated by the act of dragging and dropping them into the game itself. And once they are an instantiated object, you can, modify them or provide particular parameters to them in order to modify their behavior for the particular instance that they are operating in. But it's all object-oriented. It's all based on classes and inheritance. Once you know what's going on under the hood, anyway. The magnificent part of that is that you don't actually have to understand that theory in order to use the system. You just have to know how the system works. But it's more useful if you know how the system works. So. Yeah, ooh, do I have new reviews? Probably. So it's kind of interesting. I got a bunch of, so this particular game, I managed to get it into the, what was it? A Humble Bundle. It was the Yogscast Christmas Bundle. And I thought that was going to be wonderful, but it turned out that it was like one of 100 games, a lot of which were really not very good. So, this is my advice to all of you aspiring game developers: be very careful about bundles because they're not necessarily a good thing for you. What ended up happening, although I moved like 30,000 units by having it in this bundle, nobody bought my game particularly. And one of the things that insulates you from bad reviews is people actually having to pay for your game. There's like a psychological element of, well, I paid money for this, and I don't want to consider myself an idiot for having paid money for this, so I'm going to think better of this game that I actually paid for. Whereas if you get it for free, people are a lot more inclined to be critical of it. Fortunately, Steam doesn't, like, when you consider the review, like, I've got 100% positive reviews. Ooh, I've got a few new reviews, actually. Like, it doesn't count reviews from people who got the product for free. And I think that's a really good idea, because they're far more inclined to be negative towards the game. So if you take a look at some of these negative reviews that I've got on the game, they're actually all of them from people who got the game for free. But yeah, I don't know, maybe you consider that more accurate because they don't have that psychological, effect. But yeah. Anyway, I don't know. I know what the game is. No, I'm not giving out bonus marks for people who leave positive reviews. Nope. Sorry, that would be too much like corruption. Thank you. Yeah, so there's like, it's kind of crazy because like I didn't realize it like even up to and after the release of the game, I didn't realize who the target market for the game was, and it's your dad. It's my dad. It is dad's. It is a dad game. It is so much of a dad game. And like there's like a couple of people who for whatever reason just got super into the game and like are like stupidly good at it. Like I consider myself to be pretty good at it because I wrote it, and like for example, there's a bonus level where you have to like get up a tower and in a time limit, and the further you get up the tower, the more points you get. Like so I can do about like on a good run I can do like 240 on that. This one guy, the guy who has like 50 hours into it, he can double my best run on the tower, which is crazy. But anyway, are the benefits of object-oriented programming an artifact of limited human processing power? If programmers had perfect reasoning skills and unlimited memory, would we still use object-oriented programming? I would say that no. Pardon me. I would think that we would still use it. So, here's the thing about using abstractions, right? Like, essentially, the crux of the issue that you're talking about here is, do we use these abstractions because we have, like, these flabby meat brains that can't think exactly like computers, so we have to use these abstractions? To some extent, yes. Like, the problem is that, like, software systems are among the most complicated things that human beings have yet produced on this planet. The only thing more complicated than software is the human mind itself. And, you know, the fact that human beings are so limited in their processing power means that we need to make these abstractions, sure. But the other thing, like, even if we didn't need them, it would still be useful to have them. Because, you know, unless we had infinite processing power in our brains, there's always going to be an advantage to using abstraction to saving yourself, saving yourself the mental effort of not having the abstraction. So, you know, these abstractions allow us to program much more quickly and efficiently than we could back in the day. Like, something as simple and sort of kitschy as the pinball game, completely unimaginable to be able to do something in a computer like this, say, in the 70s. Completely unimaginable, right? And it's not just because the computers have gotten faster, it's because the abstractions that we use to program computers have gotten better over time as well, in tandem. So, abstraction is useful. There we go. Anyway, I think I should probably let you guys get through your next class, eh? So next time we'll be talking about various topics that aren't classes. Take her easy, folks. Have a good rest of your day.